Hi, good morning. Can you hear me? Okay. I'm sorry, there was a technical problem. Okay, welcome everybody to the second of a series of free webinars organized by the Horizon 2020 project MyPack in collaboration with two other EU-funded projects, GLOPACK and YPACK. We really enjoyed this collaboration. It's a way of joining forces and not only to communicate results like today, but really to learn from each other's experiences. And we do have at the end a common goal, which is work and research for better, innovative and more sustainable solutions for food packaging. My name is Beatrice Bortolozzo. I'm with 2B, which is a consortium partner of MyPack project. Today, we're going to have three presentations. Each one of them will show and explain how life cycle assessment has been applied in the specific project. We would like to leave 2-3 questions after each presentation and then really have the discussion at the end. But please, as you listen to the presentations, do write your questions in the chat. Okay, so that we can check the questions and ask them after the presentation, but mainly at the end. Our first presentation is under or over packaging, how to find the right balance between packaging and food waste. This is a case study of MyPack project. Leo Breedveld from 2B will be presented. So Leo, I give you the floor. Please share your presentation with us.
Okay, thank you very much for this introduction. I will now share my screen. Yeah. Can you see my screen? Yes? Okay, great. Okay, my name is Leo Breedveld. I work for 2B, which is an environmental consultancy located in the northern part of Italy. And I will present here the MyPack project. The aim of MyPack is to promote innovative packaging solutions in order to avoid food waste. Our role in this project is to perform the environmental assessment. So we'll do the LCA part in this project. But besides LCA, we're also doing life cycle costing. We look at the eco-efficiency and how we can optimize the packaging solutions. So that's our role. So also in my my presentation, I will focus on that part. That's also why the title is going more in that direction. So I will talk about under or over packaging and how we can optimize this by using tools like lifecycle assessment and lifecycle costing. In Europe, yearly 88 million tons of food are wasted. That's a lot. And part of the problem is also the packaging solutions that are offered. If the packaging is inadequate, it's not good enough, then you have a risk of food waste. Like in this case, a bag that's not really appropriate to pack these tomatoes. And then there is the risk of food waste. So a strategy in an under-packaging situation would be to enhance the packaging solution, and in this way try to reduce food waste. Of course, this is a balance. You must be careful not to overdo, because if you overdo, well, and then you risk to have more impact in the packaging in part and instead of the food waste reduction. So here we have an example where a lot of carton and plastic is used to pack only seven small tomatoes, and that can lead to a lot of food waste. So in a situation of over packaging, the strategy would be to reduce the packaging without increasing food waste. So the trick is really to find the right balance between optimizing packaging and reducing food waste. And that's exactly the aim of MyPack. So here an example, we have a multifunctional box that maybe also can be reused, but that might be a better solution. And in finding this balance, you need tools, and LCA is really a good tool, because with LCA you can quantify the extra packaging impact, and you can balance it with the food waste reduction. So you can see how far you should go, until which moment it still makes sense to improve or to work on another direction. Well, in order to reach this goal of MyPack, so we applied this optimization tools, lifecycle assessment and lifecycle costing, and we did this on 3 levels. So we applied LCA at the state-of-the-art level, where we applied screening LCA and screening lifecycle costing to 100 food packaging combinations in order to try to find a baseline and to see where are the under and over packaging situations. Then we applied lifecycle assessment and lifecycle costing to our MyPack technologies, so to novel packaging technologies that are proposed within the MyPack project. And well, there are a number of technologies that have been investigated, which then are also divided up into different markets. So we looked at the market of flexible films, we looked at the market of rigid packaging, and the market where a blow device has been used. So a blow device is a device where the film can breathe by means of an insertion of a device. And then finally, we also applied LCA to the end user level. So at this level, we applied the MyPack technologies at the end use cases. So we have companies present in the consortium working on different sectors. So we have a company that works with salads, a company that works with baby food, and another company that works with organic products, biscuits. And we applied the MyPack technologies to their situation to see if we could come up with innovative solutions that work better for both the environment and costs. Okay, so we applied LCA to the MyPack technologies, and doing LCA, you have to set a number of methodological choices, and 2 important choices are the functional unit and the system boundaries. So what are you going to study? Well, let's start with the functional unit. The functional unit in our LCA is defined as 1 portion of consumed food by the final consumer, and then we normalize to 1 kilogram of food. And this is somewhat different than what we see normally in LCAs, because often you see that the functional unit is defined as 1 kilogram of produced food. But by defining the functional unit at the level of the consumed food, you can see better what the impact is of the wasted food. So that's the reason why we selected here the consumed food as the functional unit. It becomes more evident what the impact is of the extra food production that is wasted. Okay. Then system boundaries. I have to put something aside. Okay, so now I can see them better. For the system boundaries, we divided the system in 2 main parts. So we have the food system at the one hand and the packaging system at the other hand. And then within the food system, we did a grouping where we have a group of the food production, so we can see what is the impact of the food production. We have also a group that indicates what is the impact of the extra food production, and with this we mean the impact with what is the impact of the extra food that is produced due to the wasted amount of food. So we have amount of food waste. This food waste also has been produced, and what is the impact of that. So by defining a different category, you can really see what is the impact of the food waste. Because of course the impact of the food waste is not that we should be disposing this food, but the main impact is because we have produced it and we did it for nothing. So this is a way how we can show better what is the impact of the food waste. Then we have a category for the food processing, logistics, food waste at retail, and also food waste at consumer, and any take-back program. Disposal of food often is not taken into account in LCAs, so you can see them here at the excluded process. The disposal of food is not considered in the LCA, but that's the normal assumption. Then we have the packaging system. Here we have packaging production, the extra packaging production due to food waste, packaging waste at retail, packaging waste at consumer, and then packaging disposal. Having divided the system boundaries in these two big systems, you can also directly see what is the impact of my food packaging combination for the food part, and what is the impact of the packaging part. So you can directly see where is the main impact, and also this will help you identifying if you are in an under packaging or if you are in an over packaging situation. Okay. I think I can go to the next slide. Okay, so we did the LCA for these 100 food packaging situations, and the primary data for these 100 LCAs has been collected for all food ingredients and also for all packaging materials. So here we use the primary data, and we also use secondary data for the other processes. And here we use data from the LCA database Aqua event. We use Aqua footprint as a database, but also we had to use other literature data like LCA publications or environmental product declarations. The life cycle impact assessment has been performed by two methods. We have used the recipe method as one of the life cycle impact assessment methods, and we used also the environmental footprint method that is promoted by the Commission. Okay, here we can see some results, and here we use the recipe method, because the recipe method also allows the quantification of the environmental impact in one single score. So that helps visualizing the results in this figure, where we can see in blue the impact of the food part, and in orange the impact of the packaging part. And we can already see that in many food packaging situations, the food impact is dominant. Here we can see 1/3 of the analyzed products. This is the middle group, to say so. So we have another group, because it didn't fit on one slide. We have another group where the impact of the packaging is even lower, and we have another group where the impact of the packaging becomes higher. Okay. Well, there are different ways to visualize the results. Here we can see the absolute values. And when we see the absolute values, that helps identifying also the outliers. You can see the strange situations. And well, if you see something strange in your graph, that is interesting to look at it in more detail, because it can be a potential under or over packaging situation. Here in green, the green line, you see the packaging impact. In brown, you see the food impact, and in blue, the total. So where you can see the outliers, there is a strange situation, and that helps us detecting the under and over packaging situations. Another visualization is the Aqua efficiency plot. We also did life cycle costing, so we could plot the environmental impact against the cost. And here we can see the cost on the y-axis. You can see the impact on the horizontal axis. And well, all 100 food packaging combinations has been plotted. Also here, the outliners helps you to detect the under and over packaging situations. So some general trends, because we try to do some clustering, so some grouping. A general trend is that whenever glass is involved, we can see a high impact, because glass recycling it's quite energy intensive. So there we see a problem with the environment. Glass you can also reuse, of course. So you can also think about a reuse scenario, but then it really comes up how many times do you need to reuse the packaging solution until you reach a break-even point. So there the amount of reuse is very important to lower the environmental impact. Another clustering we did is looking at food products with a low environmental impact, and they tend also to have a low cost. So you see some kind of correlation in this graph. Well, it doesn't hold for all points, but there is some correlation. So the lower the cost, also the lower the impact. So that would advocate the use of simple products and simple packaging. Once you add processing, is the food processing getting more complex. This means also that you have higher impacts and higher costs involved. So that would advocate the use of simple solutions. Another clustering is the clustering per food type. And also here we can see differences. Food clusters where meat or dairy products are involved often have high impacts. So here a simple advice could be, well, if you would like to reduce the environmental impact of your diet, maybe you should try to use to eat a little bit less of meat. Okay. Well, some results of MyPack. Well, MyPack is still ongoing. So what I'm showing here are preliminary results. And we can directly identify these two directions. So on the one hand, we have under packaging, and on the other hand, over packaging. Let's first look at an example of under packaging. One of the partners of the MyPack project developed a blow device, allowing a gas exchange between the inside and the outside of a packaging film. And if you add such a blow device to a package, for instance, in our case, it was the pre-cut salad, then the salad can be preserved for a longer period, increasing shelf life and reducing food waste. And so in this case, we did also the Lca study. And with the Lca study, we could see that the extra impact of the blow device actually was very, very small, because the blow device really is a low weight item. So the extra impact due to this extra packaging was very limited. But on the other hand, reduced food waste by 40%. And this lowered the environmental impact with a large amount. So this was a very good result. Then another example of over packaging. Here, the end user in the MyPack project uses rigid plastic trays for baby food. And through the use of recycled instead of virgin materials, the environmental performance of the food packaging combination can be improved, while keeping the food waste rate the same. So here, the solution was to use recycled polypropylene, and by using alternative materials, so this recycled material, it was possible to reduce the packaging impact. And also this was a very clear example where overpackaging, so the packaging impact could be reduced by using recycled materials. Well, just two examples, but exactly two examples in the directions we would like to work on. So either you can improve an overpackaging situation or an underpackaging situation. Okay, some learning points. Well, what did we learn from all those LCA studies that we did? So we did a lot of LCAs, more than 100, and what we see is that what we see is that the environmental evaluation of the packaging should be always done in relation to the food product, and you make the relation between packaging and food waste. It should also cover the entire life cycle, so also the use phase and end of life should be included in the assessment. What we see also is that often the food has a higher impact than the packaging part. And here, the first priority should be to look if the use of innovative packaging solutions can improve the protective function of packaging, and by doing this, reduce food waste and associated impacts. So first, you try to look if an under-packaging situation can be improved in order to reduce food waste. That's the first priority, because often food has a higher impact than the packaging part. And then if the food anyway is well protected and food waste is already minimized, then you can look at the over-packaging situation and try to reduce the packaging impact. For instance, by using reuse scenarios or recycling scenarios or alternative materials in order to reduce the packaging impact. Finally, environmental impacts of packaging are related to consumer habits. And so here we see that often only postponed consumption can justify the use of more complex packaging. So if I eat a product directly the same day, then I don't need a very difficult packaging solution. But if the planning is to eat this food item after a few days, then the packaging can be very beneficial by increasing its shelf life. So this directly means that the recognition of under or over packaging situations are case specific, which depends also on consumer habits. So if this salad, if we need to consume it the same day, well, then any packaging will be fine. Any simply packaging will be okay. But if the salad is consumed after 1 week, then the blow device could be crucial to prevent food waste. So what we see is that food packaging combinations are complex systems, and also consumers are involved. It's really very easily get complex. And a one-fit-all solution does not exist. So therefore, we proposed in the project, we proposed an eco-design decision tree. And we try to, with this decision tree, we try to guide present food packaging situations towards more sustainable, fit-for-purpose solutions. Well, the eco-design decision tree consists basically of following steps, where in the first step you need to assess whether the food packaging situation is an under packaging situation or an over packaging situation. And you can do this either by LCA Or you can also do this qualitatively, depending what tools you have available. Once you have identified your situation, you will go through a checklist that will help you to find a solution. So for the under-packaging solution, we have here a checklist where you need to try to improve the protective function. You can try to improve the packaging performance. You can also improve work on the secondary packaging in order to protect better the food and to avoid food waste. In case you are in an over-packaging situation, you can try to reuse or recycle the materials. You can try to reduce the weight, use less materials, you can use different materials. So here we have a checklist how you can try to improve the over-packaging situation. Once you've gone through the list, you've come up with some solutions. And then in the third step, you need to check whether these solutions really work. So you need to check again with your LCA, so this is iterative. You need to check if the solutions are really beneficial both for the environment and both for cost evaluation. And if this works well, you can go to the last step where you need to create the right conditions for the market that the packaging solution will be also uptaken by the market. And this means that you will need to work on the supply side, where you promote the market uptake of the new packaging solution. For instance, by having a convenience solution with quality, value for money, and also communication. And you also need to work on the demand side, where the packaging solution should be acceptable for the consumer. So you should also need to work on consumer acceptance, for instance, through communication. And here we come also to an interesting point, because again we have the consumer that comes into the light. Consumer acceptance can also be a potential barrier, because the consumers, they tend to associate packaging with waste problems, and by doing this they overlook the positive aspects of packaging, which can be very handy for food waste reduction. And actually, this barrier could also be transformed in an opportunity. So putting the question of over-packaging on the agenda of the consumers opens also a door to the consumers to link packaging with food waste reduction. And in this way, we can influence consumer behavior. In other words, if the consumer starts to reasoning, I'll eat the salad today, so I choose the most simply packaging solution, or he starts thinking, I'll eat the salad after a week when my parents are coming, so the packaging with the blow device is the best fit for purpose packaging since I can avoid food waste. Well, then we have gained a lot. Okay, conclusions. Food packaging combinations are complex systems, influenced by not always predictable consumer behavior. So therefore, a one-fits-all solution does not exist, but a decision tree can provide support. In this context, under or over-packaging is a starting point that can trigger the discussion on eco-efficient food packaging solutions. It's not the only issue, so there are many other issues. That's a good starting point. Other issues are consumer acceptance, procurement planning, portioning, shelf life, packaging innovation. But well, with this decision tree, I hope we can provide some guidance to more sustainable packaging solutions. Thank you for your attention. I'm not sure how I'm doing with my time, but this is my presentation. If there are any questions, I will be happy to answer.
Thank you very much, Leo, for your presentation. We haven't received questions. We had a couple of people announcing their arrival from Ireland and the Netherlands. Welcome to you all, also all those other people that joined during Leo's presentation. I do have a question for you. As a matter of fact, yes, the whole food packaging system is a very complex matter if you consider all the elements involved. And we also saw that, as you said, that people often associate the impact of food to packaging. This is something that is in consumer eye above all, it's very relevant. But according to this study, food waste has a much bigger impact than packaging. Have you also studied in which phase of the process there is the highest percentage of food waste? At the producer, at retail, at consumer?
Yes, we looked at food waste at retail and also at food waste at consumer. And for food waste at consumer, we have also a partner who quantified the percentages by doing surveys. So here we have primary data that we use in our analysis. So we use also primary data to run the LCAs for the part of the food waste at consumer. For the food waste at retail, we used literature data. So we have some idea, but both are important. Probably at I would say at consumer, we have a slightly higher percentage of food waste, but at the end both are important, and this would be also case specific. It's difficult to generalize.
Okay, thank you very much, Leo. We can move to the second presentation, which is how to deal with bio-based packaging in environmental sustainability assessment. The project presented is GLOPACK, and the presentation will be given by Lieselot Boon and Trang Nu from Ghent University. Lieselot and Trang, I give you the floor. Please share your presentation. Thank you.
Thank you for this introduction. I'll share the screen. So I guess you can see it now. So thank you for the introduction, and also good morning from my side. So today we would like to present the work we are doing in the GLOPACK project. So we are, together with my colleague Trang, we are responsible for the environmental sustainability assessment in this project. So what is this GLOPACK project about? Just a small introduction, really focusing already on what we are going to show you later on. So GLOPACK stands for Granting Society with Low Environmental Impact Innovative Packaging. And this project is still running for 1 year. The goal is to investigate food packaging with low environmental footprints and the ability to extend the shelf life of food products. So the focus is on the development of a biodegradable packaging material, and it's not only biodegradable but also bio-based, as it's coming from agri-food waste. Next to that, also some efforts are made to include active components, so to create active packaging to improve food preservation and shelf life without adding additives in the food. And then on top of that, we have a partner involved, which is developing an intelligent label, which helps to, which is an indicator for food spoilage. So these are the three things really important in the environmental sustainability assessment that we have to deal with. So what would we like to present today is, first of all, how should we measure the environmental sustainability and what are still some limitations today? And based on these limitations, we thought, how can we complement the classical LCA in order to have a comprehensive analysis on the bio-based packaging material and compared to fossil-based packaging. And we will show you some first results of the LCA study. So how to measure the environmental sustainability. So there were some expected impacts mentioned in the GLOPACK project. So things that should be come out or should be measured, not come out, but should be measured in this project or during our analysis. First of all, we hope that the packaging material can reduce waste in both food and packaging materials. Next to that, we would also like to know the change in impacts on the environment by using this GLOPACK packaging material. And this in terms of resources, global warming, and pollution in all kinds of aspects. And this packaging material should also support for the transition from a linear to a circular economy. So these are the things that should be captured in this environmental sustainability assessment. It became clear that life cycle thinking is key in this concept, as already also mentioned actually in the previous presentation. And the tool we are using is LCA, as today it is still considered as being the best framework for assessing the potential environmental impact currently available by European Commission. So it's, we try to evaluate we are evaluating and assessing the environmental impact of a product throughout its life cycle. I'm saying this because, of course, for each of the life cycle stages, we are trying to include them. And for each of these stages, we have a look what are the resources that are used and what are the emissions that are emitted or occurring at that stage. And then the amount of resources and the number of emissions are then actually translated into the environmental impact. Of course, it cannot already give a lot of information, but we saw some limitations of the classical LCA and when considering our project. First of all, sometimes it's quite difficult to communicate results in an easy way, that people that are not familiar with interpreting LCA results can also understand what is going on, to see the key messages as well. Also, not all environmental impacts are modeled properly today. For some of them, we have, for instance, cause-effect chains, but not yet characterization factors. For instance, marine littering is an example, which is, of course, important in terms of when we are talking about plastics. For a long, long time, resources were of minor importance in terms of LCA. So we actually also highlight on resource footprint and resource efficiency in our work. We think this is also quite important to be considered. And it's also sometimes difficult to find clear guidance on how to measure the contribution to circular economy. So these limitations brought us to the exercise, how can we complement the classical LCA to achieve a more comprehensive environmental sustainability assessment in order to compare bio-based packaging and fossil-based packaging in terms of environmental sustainability in a more balanced or fair way. Clearly, we start from LCA. LCA is the basis for our research, and we are following the ISO standards, and which consists then out of 4 steps, which I will not go into detail right now. But LCA is a well-developed and standardized tool. It means that there are also good building blocks for impacts, such as global warming, pollution, as eutrophication, acidification, etc. So for those aspects, we really can rely on the classical LCA. And these are things that should be included in the assessment. But then for aspects for which cause-effect chains are not well understood, or for which it's sometimes important to also communicate as such, or it's sometimes difficult to get the information from the LCA results, we think it would be good to also give some life cycle inventory data or communicate at life cycle inventory level. And then we were thinking for now on chemical preservatives or plastic losses. So in the environment after a while, what is the difference between the bio-based and the fossil-based packaging? And then food losses as well. So thinking back on the limitations, so we had first of all the fact of communications and and also the cause-effect chain, which was not always well developed, so that we had in the previous slide. Then we said that for resources, it was often it's not always included. So we really include this resource aspect as well, and we are using the SEEN methodology. SEEN stands for Cumulative Exergy Extraction from the Natural Environment. So it seems quite complex, but it's quite okay to understand, because actually we have a look to the natural resources that we need from the environment to produce our product, and this throughout the life cycle, so we have cumulative. So if we have a look, what are the resources that we extract from the natural environment, we can subdivide them in 8 categories. We have, for instance, mineral resources, fossil fuel, metals, renewables, etc. So you see here the categories mentioned. However, all of these are expressed in different units. So how can we bring them together? For that, we rely on the thermodynamic unit exergy. Exergy stands for the useful part of energy, in easy words. I won't go into detail, but it's just a way to allows us to express the amount the amount and the quantity of resources used, to express that in one single unit, namely megajoules exergy. So we can express the resource consumption in one single unit. This method has also been recommended by the European Commission as being the most comprehensive method for resource consumption. Next to that, it's not only resource consumption, but also how efficiently are we dealing with our resources during the life cycle or during the supply chain. And this is expressed then in a cumulative degree of perfection. So also this indicator will be taken into account. And then we come to the last aspect of these limitations, which was about circular economy benefits. And here we think about the credits as a result of end-of-life recovery. So what are the avoided virgin inputs due to the fact that we have a good end-of-life recovery? And this can be expressed then in reduction of global warming, pollution, or resource footprint, if we compare with fossil-based case as well. But also other indicators will be investigated, such as the circular footprint formula. So this brings us to the comprehensive framework that we were thinking on. At the left side, in the blue part, you see the examples of what will be communicated at data inventory level. And in the middle, we have global warming pollution. So these are the common LCA indicators or impact categories. And then at the left side, you see that we focus on the resources. And bringing those together, we can also talk about circular economy benefits. This is a whole framework, but the project is still running. So at this moment, we have focused on the classical LCA, and it's for this classical LCA and the resource footprint and resource consumption. So it's about that we will focus on this last part of the presentation. So some first results of the Lca study. So first of all, GLOPACK is about packaging material, as already said, but the relationship with food is of course very important, because using another packaging material might affect shelf life and thus food loss, as already explained during the previous presentation. So what we are doing is having a look to the life cycle of packed food products. So if we start at the left, we have raw material production of packaging and food ingredients, and they are both brought to the food company, so in which the food is processed and packed. The packed food product is then sent to the distribution and retail, after which it's consumed at home. At many stages, we have food losses and waste, and we have losses of packaging material. So for that one, we refer to the boxes 7 and 8 about the end-of-life treatment of both aspects. You see that some of them are indicated in gray. For those, we could retrieve primary data. For sure, regarding the packaging production of the GLOPACK material, yeah, for that one, we relied on our partners in the consortium. So what is under study in the LCA story? So we have, first of all, the GLOPACK trays or cups that are produced, and we know that there is an intelligent component as well. And as already mentioned, we compare it or we combine this with food products. So we have a ready-to-eat food, so that's falafel. We have a product with a long shelf life, cheese, and then we have beef as well. Today we will present some results regarding the falafel, so that's why they are in black and the rest is in gray. So the GLOPACK granulate that are used for the falafel is without active compound. Only for cheese, the active compound is taken into account. Then the packaging material for falafel consists out of a tray, a film, and a cardboard sleeve around it, which is also the label of this product. The manufacturing method is extrusion and thermoforming for the tray. And the benchmark packaging material is polypropylene for tray and for the film as well. The sleeve is the same for benchmark as the packaging. Before I can show you some results, I will give you some background information. So first of all, the functional units is quite important. This will be shown in some examples later on as well. We can express, if we are focusing on the granule production, we express it per kilogram granule. Later on, as it's per tray. Or if we are talking about the full life cycle, we also come to the same as before mentioned in the previous presentation, the food consumed at home. So it means that if you are consuming 1 kilogram food at home, it might be due to the losses during the supply chain that you had to produce 1.2 kilogram in the beginning. The data inventory is for the falafel case is as follows. So first of all, we have this GLOPACK packaging material. For that, we rely really on the research and industrial partners of the GLOPACK consortium. We have industrial partners, so in this case, we could collect data on extrusion, on thermoforming at industrial scale. However, the development of this tray was, and the granules was at pilot scale. So we had many talks with experts, and later on it was validated by experts as well, about how to upscale this, because we know that also comparing with similar processes, we know that some things will be more efficient as wastewater recovery, etc. So these things were taken into account, and we validated, or we also had a look at literature as well to find data on the upscaling aspect. Then the food production, what is happening at the company was also collected in a company. So there we also use primary data. But then for the other life cycle stages, we had to rely on literature, on the guidelines from European Commission, and on the database EcoInvent. Today, we will present you the results of the resource footprint, so the scene. So first, focusing on this packaging production, we have the production of the granules, which are then processed into, in this case, a tray. And next to that, you also have the production of the intelligent label. If we first have a look to the production of this bio-based granules, then we have first made from waste, agro-food residues. We have PHBV production and milled fiber coming together to form, at the end, granules. And this brings me, first of all, to the results of granule production. A lot of information on the slide, so we go through it one by one. We start at the left side, so showing the y-axis. It's the resource footprint, so it's the resource consumption for 1 kilogram of granules expressed in megajoules exergy. So the higher it is, the more resources that were used. First bar that is shown is the PHBV granules we are using for the falafel tray. The colors refer to the kind of natural resources that we are using. We understand the colors because the main aspects in this BHBV granule production is actually the electricity consumption, which is contributing the most. Next to that, we have the BHBV granule without active compounds, with active compounds, sorry. And with active compound has a slightly lower footprint as less BHBV granules are used and active compounds are used instead. And they have a lower footprint than the BHBV granules. We compared these results with what we could find in the EcoInvent database. So the next bar is about the polypropylene granule. Of course, this is mainly coming from fossil fuels, and it has a higher impact, clearly. And then the last one is PLA. Also in the database, we could find this. This is made from maize grain, and actually 37% of this impact is due to the use of the maize grain. So it means that we are using waste products, so that's why we have actually a lower impact than this PLA, which is already a more established production technology. If we come then, after the granules, we can produce trays. So that's what is presented here. So again, at the y-axis, it's the resource footprint, megajoules exergy per kilogram tray. At the left side, we have the GLOPACK material. The colors now refer to the different stages. So you can see light blue color refers to the BHBV production, and this is clearly taking or using the most resources, or is the most resource intensive stage. And then we have collected data about extrusion and thermoforming, what would be the needs for the case of our GLOPACK tray, and this is primary data. We compared it with a fossil base, and then we see that per kilogram tray, the impact for the fossil-based case is higher than for the bio-based case. Of course, we are still showing results, although we did upscaling. If the process becomes much more efficient after being an established method or technology, the results will be even more positive for GLOPACK. But at this moment, this is not yet the case. So we had better results for per kilogram tray in case of GLOPACK. But if we come now to the functional unit of one tray, we see that we need for one GLOPACK tray more mass, or 14 grams, instead of the fossil-based tray. So this results in the fact results that the GLOPACK tray has a higher resource footprint than the fossil-based tray. So this is just due to the mass at this moment. And then we come to the full life cycle of packed falafel. For sure, these are still preliminary results, but already to give you an idea, at the left side we have the GLOPACK, and the functional unit is 150 grams of falafel consumed at home. So it's the amount of falafel that is in one pack. It means that due to losses, we had to produce more falafel actually. But at this stage, we have no results yet of the shelf life tests. So it means that in both cases, for the fossil-based and GLOPACK-based case, we use the same amount of food losses at this moment, but this will be changed later on. So the colors of the bars refer to the different stages as shown before. So stage 1 is the packaging production per tray. So we know that for the GLOPACK, the impact is a bit higher than for the fossil-based tray. The second one is predominant, so that's the food ingredient production, which is quite logic, followed by what is happening afterwards. So for now, the end-of-life treatment was considered was incineration, but also here several scenarios will be considered. We do not have, so this is actually showing the first preliminary results, but as mentioned before, they will be updated or changed when we have data on shelf life tests. And we can improve food losses in this way, or the calculations of food losses in this way. We do not have a conclusion slide because at this moment we cannot recommend something yet, because we want to first of all have a full idea on this last figure. What is the amount, what is the resource footprint of falafel consumed at home, taking into account several end-of-life scenarios, taking into account food losses, etc. Also for the full framework, we really want to highlight that we also want to include the not typical categories as marine littering, etc. So that's why we are not yet at a stage to conclude or to recommend aspects at this moment. Okay, I thank you.
My name is Penny Eleni, and I'm going to give you a brief description of the polymers used in food packaging, and also some results and the conclusions regarding the LCA analysis in YPACK project. The last 50 years, plastics are widely used in packaging, to produce packaging materials because of their performance and the ease in production. Currently more than 40% of polymers global market is dedicated to packaging applications, while the 90% of them goes into food packaging. The last decades, we observed a significant increment in the production of polymers, and thus producing a very high amount of plastic waste as well. However, the rate of increase still getting higher. Mainly due to the reason that the raw materials are practically free, and even nowadays economic benefits dominate over their environmental performance. Biopolymers can be used as a solution to environmental problems caused by fossil polymers. And the relative industries try to comply with this solution. The basic principle that leads us to the use of bioplastics is to adapt renewable resources instead of fossil ones. And in order for us to be able to use them, they have to maintain the necessary final properties and also to degrade in a reasonable time. So the challenge in the food packaging industry is to go from conventional plastics that are present low biodegradability to bio-based polymers that are highly biodegradable. From an environmental perspective, there are some critical aspects regarding the production of these new biopolymers. And these are the contribution of raw materials. We have to find raw materials with negative environmental impacts. The optimization of the production process in terms of mainly the yield and the energy efficiency. Also, we have to go from the lab stage to higher TRLs, and to take also into account the logistics for the processes that utilizing these raw materials, such as collection, transportation, storage, etc. In order to assess all of these processes and products in a reliable way, we need the tool. LCA is the tool, and when we use it, we can assess the environmental impact of processes and products in all stages of their life cycle, identify hotspots, and finally provide basis for decisions towards their optimal environmental performance. Now, when to apply LCA, when some of these actions need to be taken. And these are when we need to develop and plan a new strategy, when we have to develop or improve a product, when we want to support the sourcing and upstream supply chain, and also the marketing and external communication. And why to apply LCA? As we said before, in order to assess different raw materials, to assess alternative processes, to identify hotspots of environmental impacts, and to estimate optimization potential of different steps, processes, and materials. LCA methodology follows the ISO 14040 and 14044, and according to them, the main phases of LCA is goal and scope definition, where we define the goal of the product system studied and the scope. The inventory analysis, where we gather all the inputs and outputs of our system and compile an inventory. The impact assessment, where we evaluate all this data and evaluate the potential environmental impacts. And finally, the interpretation, where we're analyzing all our results and develop recommendations. So we perform LCA analysis in the new packaging solutions in YPACK project. Here we can see the description of YPACK. As we can see, the main idea is to utilize cheese whey and almond shells in order to produce innovative food packaging solutions, trays and films, that are biodegradable and also present the required performance for their final use. The goal of LCA analysis in YPACK was to evaluate the environmental impact of these new packaging solutions and compare them with the most representative commercial ones. Regarding the scope, we define the product system, define the functional unit and the boundaries for each examined system. And we choose the most appropriate impact assessment methodology. This was Recipe 2016, the age perspective. And then, of course, we include all the necessary procedures, and we take into account all the allocation of resources. And finally, we set the requirements for our data quality. As we said, the methodology we used is Recipe 2016. According to this, we have 2 levels, one with 18 midpoint indicators and one with 3 endpoint indicators, as we can see in the tables. The functional unit for the trays was set to 1 kilo of trays, and for films, 1 square meter of films. And here we can see the product systems for the produced trays. At the left, we see the YPACK approach, and the right, the traditional approach. Sorry. And the same for the films. The YPACK approach on the left and the traditional approach on the right. And for inventory analysis, we collect our data from the involved partners of YPACK, the literature and the databases of GAPI. Impact assessment also follows the ISO 14040, and according to this, we have mandatory and optional elements that now for our methodology gives us these results. Here we can see the comparison results in climate change impact category, including biogenics for the polymer production. As you can see, YPACK PHBV present similar or even lower value than the other polymers, fossil and bio-based, that used to produce food packaging. In the next figure, we can see the tray production. Here is 4 of the most representative commercial trays from PET, PHA, PLA, and PS. And our new trays, YPAC23, 25, and 27. The overall view is almost the same. The new YPAC trays present very good behavior comparing to the fossil ones. And the next figure describes the impact in the climate change impact category, including biogenics for the films. Here we can see the even better results. Our new films, YPAC2010 and 2011, have lower values than the PP. And to close with the interpretation, Lca analysis was performed in order to evaluate our new developed product solutions and compare them with the conventional.
Well, until now, we have no results yet. They are still measuring, so we don't have any results on shelf life tests, on etc. So for now, the results you have seen is considering the same food losses for the bio-based and the fossil-based packaging case. So what we were planning to do for now is, first of all, because these results will come first, is on the shelf life test. So first find a relationship between shelf life test and food loss, and then include the food loss. So it's not really relating, not immediately going from the parameters, it's first going to the shelf life and then from shelf life to food loss. And for that, we know that we can, on the one hand, rely on literature, but on the other hand, we also have some retailers in our consortium, and they are used to model actually what is changing, if the shelf life would be less or more, how will it affect the food losses in our shops. So this will be included as well.
Okay, thank you. And of course, this is a technical information, so this is not really part of what you do, but it will be very interesting to see the developments from this side. Another question from you from European Bioplastic. Dear Mrs. Boom, could you share some information on which data set for PLA, especially for land use, you have used to model GLOPACK's materials?
Yeah, I'm not sure if I understand the question correctly, because PLA was just used as an example, just got from the EcoInvent database and was just used to compare it with our case. And in GLOPACK we start from agro-food waste, so having no impact actually. And this is transformed into PHPV granules, and then we come to our GLOPACK material and GLOPACK or the PHPV granules. So we do not have PLA in our GLOPACK case. So I don't know if this clarifies a bit.
To me, yes, but I would ask European Bioplastic if they are still present. Maybe they can activate the microphone and ask the question themselves. It's fine for us if they want to do that, if they want some extra clarification from Lieselot.
Thanks for making me able to ask the question in the audience. Yes, thanks for the clarification. I was just wondering where the EcoInvent data comes from, or if you have any more information how the higher amount for the land use production is coming from. Actually, I know this is not really what you've been looking into. It was just as a reference and to compare to, but I was just interested in it, if you have any information about it.
Yeah, so thank you for the clarification. So indeed, it's really coming from the EcoInvent database, and so they're having a check, and PLA is there available as process, and there they use a certain amount of maize, but I'm not sure, of course, if this as normally this is all validated. So, but I did not go into detail in that process. That's true.
Okay, thank you, Lieselot, and thanks to European Bioplastic. I would like to ask a question myself to Penny and Christos for their presentation. Can you tell us more about your decision of including biogenic carbon in the impact category climate change, since by default the neutral approach is generally adopted, so there was a different approach yours, so we would like to know more about your decision.
So the reason that we decide to present today this figure is to make more clear the contribution of the carbon source in our results. Of course, we have all the figures and
and we have also made calculations with without including the biogenic part of the impact. The results are more or less the same as of the comparison. The impact is a little bit higher for PHBV. However, the whole picture is not changing. What we wanted to ask here, to show here, is that the effect of using food waste as a carbon source in producing the polymer, biopolymer.
Okay, thank you for your clarification. If you have all the audience, if you have more questions, please write in the chat. I would like to ask to the three of you, which was the most difficult or the most challenging, not difficult, most challenging part of your study, of your assessment? I don't know who wants to start, who want to have Leo, and in the order of the presentations, I don't know. Leo, you would like to say something?
We have various challenges in our work. One is that we need to overlook many food packaging situations, so it's very difficult to come to general conclusions, while it's often case-specific work. That's why we came up with the decision tree, because we can't make too generalized conclusions. So therefore, we think the decision tree makes a good guidance, because many evaluations at the end are case specific. That's one issue. Another issue is that we didn't really talk about it, but also the comparisons of the bioplastics with the fossil-based plastics is quite a challenge, and we are still working on that.
Thank you, Leo. Lieselot, would like to add your point of view or your challenging part in the study?
I think all LCA practitioners can emphasize that collecting data is often the most challenging part, and here it was as well, because this is still a new technology, so it was always changing, improving. Also, to close mass balances, it took us quite some time, really, to really have all data on emissions, etc. So for now, this is for sure the most was the most challenging part. Yeah, I think maybe I can add still that
sure.
I think also what is one of our colleagues is working on that to include which is popping up the cause-effect chain of the marine littering. So also that will be still something new, and also it's nice, of course, to study on something new, but it means that it's also quite complex often. So.
Penny and Christos, so thank you, Lieselot. Penny and Christos, your point of view?
Okay, for us, it was challenging to manage to collect reliable data for different processes, especially for processes that was in low TRL level. So in order to upscale and to have real reliable data, it was a little bit challenged. However, I think we managed to use data that represents the results in industrial level, and I think they are okay, they're reliable.
Thank you very much. I have another question for Lieselot, which was interesting for me to see that the new technology tray has uses more material than the fossil-based tray. In this case, it's more or less 50%. I don't know if this will be also the case at the end of the study. But do you think that there is a break even when too much material makes a new product more efficient than another product, an older technology with a lower use of material?
It's a very interesting question. About the technical aspects, I'm not able to answer you. Maybe some other partners here present can maybe answer. But I know they are working hard on this as well. But what I can say that it's indeed interesting to calculate this break-even point. But we will only do that at the moment that we have data on food losses. We would like to do that on the packed food products, showing the importance of packaging and the importance of packaging on food.
Yeah, and you don't have these results yet, right? Okay, okay. I don't see any other question. There was, Ugo Pretato from Novamont wanted to ask a question. Would you like to be unmuted, Ugo, to ask your question?
Yes, thanks.
Okay, you're welcome.
Okay, you can also see me now. Thanks. Yes, no, it's more a general comment because I found all the presentations very interesting. I am partnering in a consultancy company which is very active on LCA, and also I represent here Novamont, which is also partner in the, as you know, in the MyPack project. Yes, all the presentations are very interesting. Just general comment, recommendation when you make comparisons, because often when you compare bio-based or biodegradable plastics with the fossil counterpart, you have from one hand very good and maybe detailed and complete primary data. On the other hand, you have to rely on secondary data that sometimes are not certain about the scope and the completeness and the general quality. And so if you want to be compliant with ISO, you should ensure as far as possible the same data quality in the comparison. And if this is not possible, this should be also reflected in the comments and presented as a limitation. And the second point is also related to the different maturity level of the technology of the products. You have on one hand fossil plastic that are well-established technologies and products with a long history of optimization. On the other hand, you have novel materials like bioplastics that have often a high potential of improvement. So I'm sure that this is taken into account in all the projects. I expect that the final results will also take into account this potential for improvement. So just be careful when you make these comparisons.
Thank you, Ugo, for your comment. Yeah, I do agree with you that I think all these projects are taking these into consideration. I don't see any other question. I do have a question for Leo regarding the fact that food waste has such a big impact, and So a lot of responsibility lies on the consumer, as you also highlighted in your presentation. So how can we reduce the food waste at the consumer, considering that is the last part of the process, you know, all decisions are made before him, and then he's there with this big impact actually also on the whole chain.
Oh, I absolutely agree. The consumer is crucial in this, and it's also the first actor that can avoid food waste. There is a relationship with packaging, and so but we should be transmit this message to the consumer, because if the consumer is going to take into account the packaging solution concerning his forecasted use of the packaging solution, so whether he will eat the product directly the same day or he will need to preserve it for a longer period, and that decision to include that is really challenging, but also could reduce a lot of impacts. For this reason, on MyPack, we also have give a lot of attention to consumer acceptance. And we have a partner working on this, the Wageningen University, and this is also the topic of the next webinar. So yes, I agree. The consumer part is very important.
Okay, thank you, Leo. I don't think there are more questions. If there is any question, please write them in the chat. Otherwise, I'd like to anticipate the next webinar, which would be on the 15th of December and would be on consumer acceptance, talking about consumers, so very interesting. Okay, so I would like to thank, first of all, Nawel Atman from the International Center for Advanced Mediterranean Agronomic Studies for organizing this webinar and the other two. Of course, I would like to thank very much our speakers for their presentations, for all the answers they've given, Leo Breitfeld, Lieselot Boon, Penny Eleni, and Christos Boukouvalis, and all those that participated in this webinar will receive